Hattie had $3,000 to invest and wants to earn 10.6% interest per year. She'll put some money into an account that earns 12% per year, and then the rest into an account that earns 10% per year. So let's make a quick equation here, a quick word equation. We could say that 12%, so there's 12% as a decimal, times the amount in the first account, because Hattie makes 12% on one of the accounts. That's how much interest right here. This expresses how much interest Hattie's going to get out of that first account. It's 12% of whatever she puts into it. And then Hattie makes 10% on the amount in the second account. And then that's supposed to equal 10.6% interest per year. So that's something we can calculate. We multiply 0.106, that's the decimal form of 10.6%. So that's too small. We multiply that times the $3,000. Because if Hattie invests $3,000 and Hattie wants 10.6% to be interest, this represents interest. So check out the structure of this equation. This is an expression of how much interest they make in the first account plus the interest they make in the second account. That should equal the interest they make total with this $3,000 that they have to invest. But now the problem is you can't do math with all these words going on. So let's say X is the amount, the dollar amount in the first account. Okay, so now we have at least some algebra we could do. So we replace the amount in the first account, all those words with X. Now watch the trick I do over here. I'm going to put in parentheses 3,000 minus X for the second account. And so think about that for a second while I fight with my computer to type the rest of this. This is an expression of how much money we have in the second account. Because together they should make $3,000, right? X is the amount of money we have in the first account. Well, then if X is 1,000, 3,000 minus 1,000, that gives us $2,000 for the second account. Or if X equals 1,500, then 3,000 minus 1,500, that gives us the amount of money we have that's supposed to go in the second account. So that little trick is what's going to get us an equation that we can solve, because now we can tighten it up instead of having all this crazy spacing. And now we can solve it like a normal equation. So we have a number in front of a parentheses. Let's multiply using the distributive property. So 0.1 times 3,000 gives us 300. 0.1 times x gives us 0.10x. And then 0.106 times 3,000 gives us 318 over here. Now we're getting closer to solving. 0.12x minus 0.10x, that gives us 0.02x. And now to solve this equation we want to subtract 300 from both sides. So it gives us 18 on this side when we subtract 300 from both sides. And then the last step here, to get x by itself, we divide both sides by 0.02. So 18 divided by 0.02. That gives us 900. So if we go back to what we said X was supposed to be, that's the amount of money in the first account. So we put $900 in the 12% account, that first account. And so that means we have to have 2,100 in the second account, in the 10% account. That was the second one that came up. Okay, let's check out the next one, see if this is similar. After 4 years in college, Josie owns $65,800 in student loans. So Josie has, it looks like Josie has two types of loans: federal loans, which has a 4.5% interest rate, and private loans, which is 2%. Usually, I think that's the other way around. Usually private loans are much more than federal loans, but I don't know. Maybe I'm wrong. The total interest she owed for 1 year was $2,878.50. So it's going to be a similar type of structure to that last one. So we could say 4.5% as a decimal times the federal loan amount, and then we got 2% times the private loan amount. That should equal total interest she owed for was $2,878.50. We don't even need the $65,800. Okay, we don't need to know that because they gave us the interest. Last time we had to calculate the interest based on the starting amount. This one they tell us there was $2,878.50 in interest. So the interest from the federal loans plus the interest from the private loans equals the total interest that we have here. And so now let's do our same type of thing. Let's call one of these X. And now over here, I'm going to say this is 65,800. Oh, wrong part of the keyboard. 65,800 subtracted by X for the private loan amount. Remember, the logic for that is because if this is X, this is going to be 65,800 subtracted by X, because like X is the amount for the federal loans. If we had $1,000 for federal loans, then you got to subtract the federal loans out of the total amount of money that we had in student loans, because they together should add up to make 65,800. And now we've got an equation we can solve just like last time. So the distributed property, we're going to multiply 0.02. So 1,316. And then 0.02x. And then we can combine like terms, so it's going to be 0.025x. And then we need to subtract both sides by 1,316. So it gives us $1,560.50. And then the last step, that's 0.025 times x. So we got to undo times with division. So it looks like 62,000. Wow. $62,500 came from their federal loans. And so that means, well, if there's a total of 65,800. Oh, I didn't copy over. There's a total of $65,800 in loans. $62,500 came from federal. So if we subtract those two, that means $3,300 came from private loans. We could just check that. That's 2% of our private loans. And then that's 4.5% of our federal loans. If you add those together, it makes the total amount of interest that they were talking about.